So far so good. But let's see like what's the issue with this simple process, because if this is it, then we don't have to do anything, right? It's a very, very simple process, but that's actually not true. Now, let's try to closely study like the intensity profile of this image. And as we go from left to right, this is the intensity profile. It kind of remains the same. It goes down. And at this point, you can see it's going down because we have kind of a dark background here, right? So it goes down, and again, it comes up. So this is kind of a more realistic intensity profile from a real world image. And you can see that it's not very smooth. There are a lot of like jerks here, a lot of ups and downs. But still, we can see that whenever the intensity is changing, we do see these dips. And these are kind of indication where the edges are present. So let's compute derivative of this intensity profile. I won't go through like all of this, but you can like do yourself, and you know like how to get these peaks, right? So this is the first one you can see here. And again, so all these peaks, they are kind of representing whenever there was a sudden change in the intensity values. And if you look at the intensity derivative, and if you look back at this image, so each of these peak is actually corresponding to the edges present at these locations. Okay, so far so good. Now let's try to add a little bit of noise like in your image. And usually we know that images are actually noisy. So let's add like a little bit of Gaussian noise and see what happens. Now, what will happen is if you have noise, you know that it comes from like a probability. For example, if it's a Gaussian noise, so each pixel will have some value added, right? Or maybe subtracted. And if you, let's say, add Gaussian noise on this image, then the intensity profile is going to look like this. And no, so this is the intensity derivative. And here you can see that, okay, the edges which you were observing earlier, they are kind of gone, right? So you are seeing like a lot of peaks here. All of these are peaks. Of course, you have like higher peaks, which is fine, but you do have like shorter peaks as well. So now the question is, if we observe that many peaks, of course, those are not edges, right? Those peaks are there because of noise, because due to noise, like your pixel values are actually changing in the local neighborhood. And that's why it's hindering you from computing the actual edges. Okay, so this is a simple function. Again, consider this as like intensity profile coming from an image. And you can see like there's a lot of fluctuation in the signal, which is again coming from noise. Okay. Now, if you compute a derivative, as I showed you earlier from a real example, even for this function, this is what like a first order derivative will look like. And at each location, since the pixel values actually intensity is changing, you will get a lot of peaks. Whenever it's changing, you will get a peak. And with this kind of signal, you can't say where the edge is present. So let's try to see what can be like a simple solution to resolve this. Okay, so all this is fine. We talked about that.